Students, do you see my screen?
Yes, sir.
Okay, fine. So we are discussing random variables. So random variable is related to probability. So if you perform a certain experiment, what are the all possible outcomes? That creates the sample space. For example, if you toss a coin, either it is head or tail. If you toss two coins, then the outputs, possible outputs are both are head, both are tail, one head, first one is head, second one is tail, or first one is tail, second one is head. So these four are the or possible outcomes. If you throw a single die, then either 1, 2, 3, 4, 5, 6, one of these values will be appearing on the top. So these are the all possible outcomes if you throw a single die. So these outcomes, all possible outcomes, they create the sample space. And a random variable is a function defined from sample space to real line. That means each possible outcome will be associated with a real number. So that we have seen. Now random variables are divided into two parts. One is a discrete random variable and another is continuous random variable. So we'll study some set of discrete random variables and some set of continuous random variables, and we are going to study what is the expectation or mean of those random variables, both continuous and random case. And these are the formula we also have written. Expectation of discrete random variable will be average value of the random variable. Average value of the random variable in the sense of weighted average. So summation xi pi. Xi is the random variable. Xi is the value random variable is obtaining, and pi is the corresponding probability for the random variable x to assume the value xi. So summation xi pi is the expectation or weighted mean of the random variables. For continuous part, counterpart for the continuous random variable is expectation or mean is equals to integration minus infinity to plus infinity x time f of x dx. So this is the formula for mean. Just a moment. हाँ मैडम, मैं आपको थोड़ा बाद में फोन करता हूँ, मेरा क्लास चल रहा है. ओके हाँ. So this is the formula of mean in discrete case and in continuous case. What is the explanation for mean? Mean is the, in discrete case, mean is the weighted average of the random variables, and in continuous case, mean is the x value or the average value of the random variable where center of mass is lying. So basically you are finding center of mass of a curve, that is represented by expectation or mean. Similarly, variance of x in discrete case is given by this formula here. This is the value of expectation of x minus mu whole square. So if you know how to define expectation, so that will be summation over I xi minus mu whole square into pi. So that is the expectation, that is the variance in discrete case, and in continuous case it will be integration minus infinity to plus infinity x minus mu whole square into f of x dx. So this is the variance in discrete case and in continuous case. What is the physical significance of variance? Variance tells you how much variation are there in the data points or in the random variables. What is the average distance between the mean? What is the average distance between the mean and all other random variables? So that is given, that is the significance of variance in discrete case. In continuous case, variance represents moment of inertia about perpendicular to the axis passing through the center of mass. So that is what variance is representing in case of continuous random variable. And sigma is standard deviation. Sigma is nothing but positive square root of variance. So this is standard deviation. Standard deviation अगर ज़्यादा होते हैं तो data they are distributed widely, and if variance or standard deviation is small, then data are congested about the mean, congested around the mean, and if it is large number, then they are spread, they are widely spread. So these are the meanings of expectation, variance, and standard deviation. We also have seen some discrete random variable. We have not seen any continuous random variable. So continuous random variable is a random variable which is taking values in a certain interval, all the values in a certain interval. Okay. So we are getting probability mass function for discrete random variable, probability density function for continuous random variable. Also, we are getting cumulative distribution function for both the continuous and discrete random variable. So here is one such example of continuous random variable, the probability mass function of the probability density function. Sorry, in case of discrete it is probability mass function, and in case of continuous it is probability density function. So here it is one such example. So time taken by a garage to repair a car is a continuous random variable whose probability density function is given as whose probability density function is given by fx of x is equals to 3 by 4 x into 2 minus x when 0 less than equals to x less than equals to 2, and 0 elsewhere. So what does mean by this function? Function is defined as 3 by 4 x into 2 minus x when x is lies between 0 and 2, and 0 elsewhere. So the random variable x takes values from 0 to 2. It takes any values from 0 to 2. You see? And what is the density function? What is the corresponding probability? 3 by 4 x minus 2x. So what does mean by that? If you are taking your car to the garage, so it will tell you what is the probability that the car will be fixed. So it is certain that the car will be fixed within 2 hours. Whatever problem you have with your car, it will be fixed. According to this random variable, your car will be fixed within 2 hours. It is guaranteed. Why? Because the total probability is 1. You calculate integration minus infinity to plus infinity fx of x dx. What is the integration value? Can you tell me? If it is not 1 minus infinity to plus infinity, then fx cannot be a probability density function. So it has to be 1. If it is not, then it is wrong. So what you are getting in the current scenario, what is the value of the integration? So here in the current scenario it is 0 to 2, elsewhere is 0. So 0 to 2, 3 by 4 x into 2 minus x dx. What is the value of the integration? What is the value of the integration? And f of x is greater than equals to 0 for all x. Whatever value of x you choose, that is greater than equals to 0. So that is the first condition for a function to be a density function, probability density function. And second condition is total area under the curve has to be 1. So what is the area in this case? It is 1. You check it. So it is a probability density function, correct way it is defined. So what is represented by this density function? So it tells you that whatever problem you have with the car, it will be fixed within 2 hours. What is the probability that the car will be fixed within first 5 minutes? Then you have to accordingly integrate. What is the probability that the car will be fixed within first 5 minutes or first half an hour? So half an hour will be integration from 0. It is given in terms of hour. So 0 is 0 hour, 2 is 2 hour. So what is the probability that your car is fixed within half an hour? So you have to calculate this integration. 0 to 0.5 3 by 4 x into 2 minus x dx. Whatever value we are getting, that will be the probability that your car will be fixed within half an hour. What is the probability that your car will be fixed within 1 hour? So you have to integrate integration 0 to 1. Okay. 3 by 4 x into 2 minus x dx. Whatever value you will be getting, that will be the probability that your car will be fixed within 1 hour. So it tells you how the probability is distributed in the interval 0 to 2. Remember, this is probability density function 3 by 4 x minus 2x, and here is the value which is obtained by the random variable. Random variable x is assuming values from 0 to 2. So it is a continuous random variable, and its probability density function is given by this. So this is one such example where we are encountering real life problem. The real life problem is dealt with probability density function. Now, how do we get these probability density functions? How do we get? So it is observation. It is observation. We'll describe few more example. We'll discuss. Then you'll get to know. So these probability density functions are coming from observation, or the observation of the experiments, or observation of the experimenter. So what we are going to do, we are going to study some specific discrete and continuous random variable and their mean or expectation, variance, and standard deviation. And we are also going to solve few problems using those discrete and continuous random variable. So first random variable we are going to consider will be discrete type, which is defined as discrete uniform distribution. So discrete, some discrete random variable. Okay, so first one is uniform discrete random variable. So suppose x is a random variable. X is a random variable which assumes the values suppose 1, 2, 3 up to capital N with equal probability, with equal weight, with equal probability or weight, equal probability. What kind of probability you are considering? For example, you are throwing a die. And you are defining a random variable from all possible outputs to real line as x of the output is equals to face value. So x of 1 is 1, x of 2 is 2, x of 3 is 3, x of 4 is 4, x of 5 is 5, and x of 6 is 6. So that random variable assumes the value from 1 to 6, and that random variable is having equal probability to assume the values 1 to 6 if you throw a die. Okay. So what is the probability that the random variable x is assuming the value xi here? What is the probability that the random variable x assumes the value xi in discrete uniform distribution is 1 by n. For each point, it has same probability. So what is the expectation of this distribution? So expectation of this distribution will be what? Summation xi into pi. So summation, how many points are there? N points are there. So I equals to 1 to capital N. Xi is what? Xi is what? I. What is pi? Pi is 1 by n. So this is 1 by n is outside. Summation I equals to 1 to capital N. So what is the sum?
N into n plus 1 by 2.
N into n plus 1 by 2 and one more n is there. This n. So 2n. So this n will be cancelled out. N plus 1 by 2. So this is the average, weighted average of all these random values. All these values which random variable is assuming. So this is the average. Okay. What is the variance? What is the variance of this random variable? Var of x. So this is what? Expectation of x minus mu whole square. Mu is expectation. Okay. So this is expectation of, let me write down the general expression. Expectation of x minus mu whole square. So this is what? By definition, summation I equals to 1 to n xi minus mu whole square into pi. Pi means probability at x equals to xi. So this is summation I equals to 1 to n xi minus mu whole square into 1 by n. Now you have to simplify it. Before we simplify it, let us write down few alternative formula for variance and expectation. Because directly it will be a bit difficult to evaluate. You can do it. No harm is there. You can use the formula. So what you do? You first expand it. 1 by n is outside. Summation I equals to 1 to capital N xi minus mu whole square. So 1 by capital N, you first remove the square, expand the square. So this will be xi square minus 2 mu times xi plus mu square. So what it will be? 1 by n is outside. What is summation xi square? N into n plus 1 into 2n plus 1 by
6.
6. So that is the first part. Minus 2 mu. 2n mu constant. So that will be coming out of the summation. What is summation xi? N into n plus 1 by
2.
2. Okay, so let me write down clearly. So n into n plus 1 by 2. N into n plus 1 by 2 plus mu square into summation 1 n times. So what it will be? Mu square into 1 1 1 1 up to n times. So it will be n. Okay. Now you simplify it. You can simplify. So it will be coming, if you simplify, it will be coming n square minus 1 by 12. So this is the variance of this discrete uniform distribution. This tells you, this gives you a measurement how widely the data points are distributed about the mean. So mean is n plus 1 by 2. So n plus 1 by 2 से दोनों साइड में जो रैंडम वेरिएबल की जो वैल्यूज है वो कितने widely distributed है, that is given by this quantity n square minus 1 by 12. Now let us consider alternative expression to calculate variance. Otherwise, it will be a bit difficult at later stage. Just a moment. So variance, alternative formula for variance. Okay. So what is variance? The formula for variance, you can consider either continuous case or discrete case. Both derivation will be similar. So variance of Ax is what? According to the formula, according to the definition, E of expectation of x minus mu
square.
whole square. What is mu? Mu is expectation or mean of the random variable x. Okay. So how we can rearrange it? So alternative formulas are given by variance of x is equals to E of x square minus E of x whole square. So basically that is E of x square minus mu square. This is one alternative formula for variance. Another formula is, so depending on the random variable, one of these formulas will be used. Variance of x is equals to expectation of x into x minus 1 minus expectation of x into expectation of x minus 1. If you use the symbol mu, so it will be expectation of x into x minus 1 minus mu into mu minus 1. Mu is expectation of x, mean of x. So these are the alternative formulas. The derivation is very easy. We can derive from the definition. We can derive it from this definition, these alternative formulas. Let us see. So what is x minus mu whole square? Expectation of x minus mu whole square. So derivation of first one. So expectation of x minus mu whole square will be expectation of x square minus 2 mu times x plus mu square. Now remember expectation, so there will be two derivation in case of continuous case and in case of discrete case. Both kind of definition will be true. So let us first derive it for the discrete case. So what is this? This is summation value of the random variable into corresponding probability. So suppose corresponding probability is pi. So this will be xi square minus 2 mu xi plus mu square into corresponding probability in case of discrete case. What it will be in case of continuous case, I will be writing it later. So this is discrete case. So it will be, now summation is distributive. Yeah, you can consider separate summation. So it will be summation xi square into pi minus 2 mu summation xi pi plus mu square into summation pi. So what is this by definition? Xi square into pi. This is expectation of x square. Expectation of x square minus 2 mu. What is xi pi?
Expectation of x mu.
Expectation of x, which is mu. You see at the top. So it is mu plus mu square into summation pi. What is summation pi for any random variable?
1.
What is the sum of total probability?
1.
1. So it into 1. So 2 minus 2 mu square plus mu square. So it will be minus mu square. So it is expectation of x square minus mu square. So that is what is the first formula. So this is the derivation in case of discrete case. Continuous case, it will be same derivation. Let me show you. So expectation of x minus mu whole square, this is by definition, if it is a continuous random variable, minus infinity to plus infinity x minus mu whole square into f of x dx. What is f of x? F of x is the corresponding probability density function of the random variable x. So this will be equals to minus infinity to plus infinity x square minus 2 mu x plus mu square into f of x dx. So this is minus infinity to plus infinity x square f of x dx minus 2 mu minus infinity to plus infinity x f of x dx plus mu square integration minus infinity to plus infinity f of x dx. Okay, so since f of x is probability density function, total probability will be 1. Total area under the curve will be 1. So this is 1. This is equals to 1. And what is this part? And what is this part? So this part is by definition expectation of x square. You see the definition of expectation in case of continuous and discrete case. See? Okay. So expectation, this is expectation of x square minus 2 mu, this is the expectation of x plus mu square into 1. So expectation of x is mu, so basically it is same thing, expectation of x square minus 2 mu square plus mu square. So expectation of x square minus mu square. So you see same derivation, same formula we have obtained irrespective of the distribution. Okay. Similarly, second derivation also you can show. So I'll be showing it in case of here it will not be depending. I can independently prove it. So proof of the second formula of variance. Okay. Okay. So what is variance of x? Again, by definition, this is expectation of x minus mu whole square. So this is expectation of x square minus 2 mu x plus mu square. So what you do, you add x, subtract x inside of this term. So x square minus x minus 2 mu x plus mu square plus x. Is it okay? So this will be expectation of x into x minus 1 minus 2 mu x plus mu square plus x. So if you simplify it, you'll get, you can use any definition, either discrete case or continuous case. Expectation is linear, so it will be, or you do not have to know the formula, you directly evaluate, either use discrete case or continuous case. So ultimately you will get expectation of x into x minus mu or x minus 1, first term जो है x into x minus 1 minus 2 mu expectation of x plus mu square, expectation of 1 is 1, expectation of 1 is 1, mu square into expectation of 1, okay, plus expectation of x. So that will be expectation of x into x minus 1 minus 2 mu square plus mu square plus mu. So that is giving you expectation of x into x minus 1 minus mu square plus mu. So that will give you expectation of x into expectation of, just a moment, expectation of x into x minus 1 माइनस म्यू को कॉमन लेते हैं तो आएंगे म्यू माइनस 1. तो वही आपको प्रूव करने थे, देखो. Okay, so this is what it do. So that is the second formula. So one of these formulas will be used to derive expectation and variance of random variable. So that was, first one was discrete uniform distribution. Second important discrete distribution is binomial distribution. It has huge application, lots of application. So binomial distribution. Binomial distribution. So suppose you are performing certain experiment, two possible cases are there. Either your prediction will be true or your prediction will be false. So two possible outputs are there. Somehow you have to arrange your experiment in observation in such a way that there will be only two possible outcomes. So E is an experiment and it has only two possible outcomes. Either it will be a success or it will be a failure. Just a moment. So E is random experiment. I'll give some example, then it will be clear to you. First, you will listen carefully. So E is a random experiment. Okay. A is an event, an observation. Now either A will be happening or A will not be happening. So suppose probability of happening A is given by small p. Then what is the probability that A will not be happening? Either A will be happening or A will not be happening. Total probability is 1. So suppose probability of happening A is given by small p. So what is the probability that A will not be happening? What is the probability that A will not be happening? For example, let me give you an example. Otherwise, it will not be clear.
1 minus
Suppose
p.
you are throwing a die and you want your output to be exactly 1. Okay, so values on the face of the dice are 1, 2, 3, 4, 5, 6. If you throw a single die, either it will be 1 or 2 or 3 or 4 or 5 or 6. At least one of them is going to appear on the top. So suppose I'm asking, what is the probability that, so what is the success? If you get value 1 on the top, then your observation will be a success, event A will be a success. If you do not get 1, then it will be a failure. Then what is the probability that A is true? On the top there will be 1. The probability that your event will be a success means you will be getting 1 at the top of the dice in a single throw. What is the probability? 1 by 6. What is the probability it will be a failure? Failure means it will be something else other than 1. So what is the probability of failure?
5 by 6.
5 by 6. So 1 minus the probability of the event. That will be the probability of the complement of A. So 1 minus P. So you have to arrange your observation in such a way that either it will be a success or it will be a failure. Only two possible cases are there. So probability of success is A and probability of failure is given by 1 minus P, which is a special notation for Q. So probability of success is P, probability of failure is Q. Then if you repeat the experiment n times, so repeat the experiment n times, and out of n times you want exactly R success. Out of n times you want exactly or you do not have to write exactly because we can later manipulate it. So you want R success. What does mean by that? Suppose you are throwing the single die 3 times in a row. First time, if you get 1, it will be a success. Second time, if you get a 1, it will be a success. Third time, if you get a 1, it will be a success. So out of those 3 repetition, you want at exactly 1 time, suppose. Then what is the probability of getting 1 success out of those 3 repetition? So that probability is given by, probability distribution is given by this binomial distribution. So repeat the experiment n times, and out of n times you want R success, then the probability distribution is given as probability that the random variable x is assuming the value R, means you are getting R success, is equals to, so random variable x denotes how many success you are getting. Random variable x denotes how many success you are getting. Okay, so probability that the random variable is assuming the value R is given by NCR P power R Q power n minus R. So this is the probability mass function of binomial distribution. What is the value of R? R may be 0, so you want 0 success, you want 1 success, you want 2 success, or you want n out of n success. So n success out of n trial. So this is the binomial distribution. Now we are going to analyze its expectation and variance later. Let us solve few more examples using this binomial distribution. For example, you are appearing in a quiz. There are 10 questions. In a quiz, 10 questions are there. Okay, each question having 4 options. 10 questions. Each question having 4 options. 4 option. So 4 options. So if you guess it, simply guess it, any question, what is the probability? Out of those 4 options, 1 is correct. So this is multiple choice question. So suppose you are guessing arbitrarily, what is the probability that for any question it will be a correct?
1 by
It will
4.
be correct option?
1 by 4.
1 by 4. So now I am asking, okay, what is the probability that out of 10 questions, 10 will be correct if you simply guess them? Or what is the probability
1 by
that
4
out
raised
of
to
10
power 10.
questions, out of 10 questions, 5 will be correct, or out of 10 questions, 3 will be correct. So you want success, you want to repeat the guessing experiment 10 times, and out of 10 times, how many success you want? It is depending on the desire. So either you want 2 success, 3 success, we want to calculate the values, the probability of corresponding successes. So what is probability of success?
1 by 4.
1 by 4. What is the probability of failure? Q?
3 by 4.
3 by 4. Now 10 questions are there, and each question having 4 options, and you are simply guessing it. So what is the probability that out of 10, 5 will be correct? Probability that out of 4, out of 10, 4 will be correct, or 5 will be correct. Let's say 4. Out of 10, 4 question will be correct. 4 option will be correct. So how do we get this distribution? This is from observation, that this guessing game will follow this kind of binomial distribution. So you can apply this binomial distribution and you can find out your probability. This is simply an observation. How do we get it? These 4 questions may be any 4 question out of 10. So that is why NCR is taken. Now for each question probability they are independent. So for each question probability of success is P and corresponding probability for failure is Q. So how many questions will be correct? R questions will be correct. So P power R, and how many questions will be wrong? N minus R. So that is why Q power N minus R. So it will be 10C4 P power 4 Q power N minus 4. So 10 minus 4. N is 10. 10 minus 4. Now you substitute the values and simplify. 10C4 1 by 4 power 4 3 by 4 power 6, and you simplify, you will get a real number close to, I do not know if you simplify it, maybe it is close to 2 or 3, maybe it is close to 4.4. It will be a number between 0 and 1. So if you want 10 questions out of 10 to be correct, you will see that value will be very close to 0, and obviously that is happening. If you guess 10 questions and you want all 10 to be correct, it is very unlikely to happen. So the probability will be very close to 0, and you will get the same thing from there, from this distribution. So this is this MCQ question which can be solved this using this binomial distribution. Few other problems are there which you can solve using this binomial distribution. For example, in a family of 4 children, what is the probability that there will be exactly 2 boys? So you can use this probability distribution, though these problems are very simple. So what is the probability that 3 rolls of a pair of 6-sided dice, exactly one total of 7 is rolled? So a pair of dice are rolled together 3 times, and what you are doing basically, you are counting the sum of the face values. So what is the probability that exactly one total of sum will be appearing? One total of 7 will be appearing. So that also can be solved using this binomial distribution. So we are going to discuss the expectation of this binomial distribution and variance of this binomial distribution. So what is expectation of x? By definition, this is discrete case. So it
Sigma
is summation
xi
over I xi into pi.
pi.
So what is the random variable taking the values? Random variable taking the values. You see x denotes the how many. X is the random variable that denotes the success. How many success you want? So what are the values random variable x is assuming? 0, either 0 success or 1 success or 2 success up to n success out of n trial. So random variable x is taking values x equals to 0, 1, 2, 3 up to n, and their corresponding probabilities are given by NCR P power R Q power n minus R. Okay, so summation xi pi, that will be, so random variable is taking the values I, R is running from 0 to n. Okay, so this is the random variable x is taking values R, xi equals to R, and corresponding probability is NCR P power R Q power n minus R. So this is the expectation of the binomial distribution. Now you have to simplify it. You have to simplify it, and you see what you are getting. So for I equals to 0, so R, this is R, this is R, not I. So for R equals to 0, it has no contribution. So basically this sum is from R equals to 1 to n R NCR P power R Q power n minus R. So this can be written as summation r equals to 1 to n r. What is NCR? NCR is n into factorial n into factorial. What is NCR? Factorial n by
R factorial n minus r.
factorial r into factorial n minus r into p power r q power n minus r. Somehow you have to simplify this sum. So let us see how we can do it. So summation r equals to 1 to n r. I am taking n outside, 1 n. So inside will be factorial n minus 1. Factorial n is n into factorial n minus 1. So that n I am taking outside. So inside is factorial n minus 1. In the denominator it will be r into factorial r minus 1. Factorial r is r into factorial r minus 1, and n minus r can be written as n minus 1 factorial minus r minus 1 factorial. No changes is there. So 1 minus 1 will be cancelled out. P power r minus 1, 1p I am taking outside. So this is a known manipulation. If you do not know, it is very difficult to find out the values. So 1 n was outside and I am taking 1p outside. So p power r में से मैंने एक p बाहर निकाल दिए. So it will be p power r minus 1 and into q power n minus 1 minus r minus 1. कुछ चेंज नहीं किए, बस थोड़ा रीअरेंज कर दिए n minus r को. So this r will be cancelled out. So what you are getting, np into summation r equals to 1 to n factorial n minus 1 by factorial r minus 1 factorial n minus 1 minus r minus 1 p power r minus 1 q power n minus 1 minus r minus 1. Now what you do, you change the indices. You change the index r from something else so that it starts from 0. We want to write down p plus q power something. P plus q power something. Okay. So if you change this index from r to s, what it will be? What is the upper limit of s? Suppose s is r minus 1. S is r minus 1. Then what is lower limit of s?
0.
Lower limit of s is 0. So np summation lower limit will be 0. S equals to 0. What is upper limit?
N minus 1.
N minus 1. So n minus 1 will be what? So it will be n minus 1. R minus 1 is s. So n minus 1 cs. P power s. Q power n minus 1 minus s. Is it okay?
Yes, sir.
So this is what by definition? np is outside. This is p plus q power n minus 1. Binomial expansion of the term p plus q power n minus 1. Is not it?
Yes, sir.
So what is p plus q?
1.
1. Probability of success plus failure is 1. So this is 1. This whole term is 1. So you are getting n into p. So this is the average value of the random variables with respect to the corresponding probabilities. So it is not a simple average. It is weighted average. For each random values, it has corresponding weight. If you want r, these are the values. Random variable x is assuming 0, 1, 2, 3 up to small n, and it has corresponding probabilities, certain probabilities depending on each success you will get. So you have to take this weighted average. So this weighted average is np. expectation or mean of the random variable. Similarly, you have to calculate variance. So to calculate variance, you have to use this formula. Variance of x equals to expectation of x into x minus 1 minus mu into mu minus 1. Mu is expectation of x. So it will be expectation of x into x minus 1. If you use something else, it will be very difficult. Minus np, mu is np, we have already calculated, into np minus 1. So you only have to calculate this part, expectation of x into x minus 1. So same type of technique we are going to consider. So let us calculate this part. So variance of, so suppose this is equation number 1. So here expectation of x into x minus 1, that will be by definition summation r into corresponding probability. So r into r minus 1, random variable x into x minus 1 is assuming r into r minus 1 into corresponding probability n c r p power r q power n minus r, and r is running from 0 to n. So for r equals to 0 and r equals to 1, there will be no probability. It will have 0 probability. Not 0 probability. This expression will be 0 because r into r minus 1 is a factor. So basically it can be written as summation r equals to 2 to n r into r minus 1 ncr p power r q power n minus r. और जो पहले मैनिपुलेशन किए थे वैसे ही आपको मैनिपुलेट करना पड़ेगा. So you take n into n minus 1 into p square common. So if you take n into n minus 1 into p square common, it can be written as summation r equals to 2 to n r into r minus 1 will be cancelled out. So it can be written as n minus 2 c r minus 2 p power r minus 2 q power n minus 2 minus r minus 2. So this is how you can write if you take n into n minus 1 into p square common. So whole thing you change the index from r to s. How? You decrease the index by 2 amount. So it will be n into n minus 1 into p square into p plus q power n minus 2. It will be coming. So this expectation of x into x minus 1 will be coming n into n minus 1 into p square. So now you have to substitute this value in equation number 2 to get variance of x. So variance of x will be variance of x for binomial distribution is n into n minus 1 into p square minus np into np minus 1. इसको सिंप्लीफाई करो, देखो क्या आ रहे हैं. सो np n और p को कॉमन ले सकते हो. np को कॉमन ले लो पूरे टर्म में से. सो इट विल बी n minus 1 into p minus np plus 1. No. Is it the case? Okay, this is the case. One minus c. Okay. So this is np. Inside में है np minus p minus np plus 1. So np cancel out. So it is np 1 minus p. So 1 minus p is what? Q. So this is npq. So this is the variance of the binomial distribution. What does it tell you? How far the probabilities are distributed, random values are distributed about the mean value. So this is the variance of the binomial distribution. Okay. In next class, we are going to consider one more discrete random variable which will be known as Poisson random variable, which has huge application in real life. We are going to solve some problems using that, and then we are going to consider two continuous random variables. One will be uniform distribution and another will be normal distribution or bell curve or sigma curve. Then this distribution part will be completed, and then we'll consider one or two class on regression analysis, and then the whole syllabus will be completed. So we need 3 to 4 more classes to complete the syllabus. Okay, so any question from this random variables, continuous and discrete?
No, sir. No, sir.
Okay, fine then.